Hello students, how are you all? I hope that you all are good. So as we know, the series of motion in a straight line is going on and we are successfully finished the 3 lectures. In our last lecture that we are discussed about instantaneous speed and instantaneous velocity. So the difference between instantaneous speed and instantaneous velocity is what? So instantaneous speed is equals to delta x by delta t, where x tends to distance. So whenever delta t tends to 0, that means the change in time is very small. Then we can write instantaneous speed as a dx by dt. In case of instantaneous velocity, so we can write instantaneous velocity is equals to delta s by delta t, where s tends to displacement. Whenever the time is very small, delta t tends to 0, therefore we can write, so instantaneous velocity is equals to ds by dt, and we have solved some problems on that instantaneous velocity and the instantaneous speed, right? So in this session that we are going to discuss about acceleration. So what is acceleration, what is instantaneous acceleration, what is average acceleration, and some problems on instantaneous average accelerations, and also, so whenever the velocity is given, how to find the displacement, whenever the acceleration is given, how to find the velocity. So all these things that we are going to discuss in today's session. So my name is Rakesh. Welcome to our beautiful physics channel, Rakesh sir Physics. Shall we start the session? Okay. So what is the chapter going on? Motion in a straight line. And now this is what? Class number 04. Class number 04. So what is the topic today? The topic is what? Acceleration. What is the topic today? Acceleration. So what is the meaning of acceleration? Acceleration means from your childhood onwards you are studying acceleration, about acceleration. So what is acceleration? The rate of change of velocity is called what? Acceleration. The simple definition. So what is the simple definition of acceleration? The rate of change of velocity is called acceleration. Is called what? Acceleration. Are you getting? Okay. So acceleration is a vector quantity. Acceleration is a vector quantity. So already we have discussed about a vector quantity and a scalar quantity. What is vector quantity? If the physical quantity having both direction as well as magnitude, such type of physical quantity is said to be what? Vector quantity. Okay. So SI units are meter per second square. SI units are what? Meter per second square. And again now, acceleration can be classified into two types. Acceleration can be classified into two types. First one is average acceleration, and the second one is instantaneous acceleration. Instantaneous acceleration. Are you getting? Have a look. What is the meaning of acceleration? So the average acceleration is equals to change in velocity divided by change in time. Change in velocity divided by change in time. Are you getting? So the change in velocity can be written as final velocity. I'm just writing like this: final velocity minus initial velocity divided by final time minus initial time. So this is called what? Average acceleration. Are you getting? Any doubts? So average acceleration is this. Instantaneous acceleration. Instantaneous acceleration, which is equals to delta v by delta t. Instantaneous acceleration is equals to how much? Delta v by delta t. If delta t tends to 0, that means it's a very small. The change in time is very small. Then we can write instantaneous acceleration is equals to limit delta t tends to 0 delta v by delta t is equals to dv by dt. So finally, instantaneous acceleration can be written by dv by dt. Are you getting? So all these things that we are discussing from last two lectures. Okay. So this is not a new thing. Okay. So already we are discussed in the last two sessions. Have a look. dv by dt. So what is its meaning? The slope of graph of v versus t, velocity versus time, gives instantaneous acceleration. The slope of graph of velocity versus time gives what? Instantaneous acceleration. So all these things we are discussed in a speed concept, a velocity concept, or displacement, and all these in all previous sessions we are discussing the same thing only. Okay, nothing new is there. So pause the video and write the notes. Pause the video and write the notes. 3, 2, 1, go. Right. So have a look. The examples on average acceleration and instantaneous acceleration. So the first example. So I'm going to take off. The velocity of the object is given like this. Velocity is equals to t cube minus 2t square. Find out acceleration at a t is equals to 2 seconds. Find acceleration at a t is equals to 2 seconds and average acceleration at t is equals to 1 second and t is equals to 3 seconds. Okay, so this is the given question. What is the given question? So velocity is equals to t cube minus 2t square. Find the acceleration at t is equals to 2 seconds and the average acceleration at 1 second and 3 seconds. So this is the given question. Pause the video and try the solution. 3, 2, 1, go. Have a look. Solution. So we can take out velocity is equals to t cube minus 2t square. So this is the given velocity equation. What they are asking? Find the acceleration at t is equals to 2 seconds. So have a look. Now we have to differentiate this term, right? So which is equals to d by dt of t cube, d by dt of x to the power of n, n into x to the power of n minus 1. Now at the place of n we have 3. So n into x to the power of 3 minus 1, you will get 2 minus 2t square. 2 is constant, differentiation of t square, 2 into t. So finally we got acceleration is equals to 3t square minus 2 to the 4t. So this is what equation of acceleration. So what we have to find? We have to find instantaneous acceleration at 2 seconds. Just substitute 2 at a place of t. Then we will get 3 into 2 square minus 4 into t, which is equals to 3 into 2 square, 4. At the place of t, we have to substitute 2. 4 to the 8. So 3 4 the 12 minus 8. So that is equals to 4 meter per second square. So instantaneous acceleration is equals to, we got how much? 4 meter per second square. Are you getting? Right. Next, what we have to find? Average acceleration at a t is equals to 1 and t is equals to 3 seconds. So average acceleration is equals to change in velocity divided by change in time. Change in velocity divided by change in time. Just take the velocity equation. So what is the velocity equation? V is equals to t cube minus 2t square. So time given 1 second, 3 second. T is equals to 1 second. Let us say this is t1 and the t2 is equals to 3 seconds. Are you getting? Just substitute here. Then we will get v1 at a, just write like this, velocity at a t is equals to 1 second, then we will get 1 cube minus 2 into 1 square, so which is equals to 1 minus 2. 1 minus 2 is how much? Minus 1 meter per second. Next, where we have to find velocity at a t is equals to 3 seconds. Velocity at t is equals to 3 seconds. Just substitute 3 at the place of t. So we get 3 cube minus 2 into 1 square, sorry 3 square, which is equals to 3 3s are 9, 9 3s are 27 minus 2 into 3 3 is a 9, 9 2 is a 18. So 27 minus 18. So you will get a 9 meter per second. So now we can write a average acceleration. So average acceleration is equals to v3. So final velocity minus initial velocity divided by t final minus t initial. What is the final velocity? 9 minus what is the initial velocity? Minus 1 divided by what is the time final? 3 seconds minus what is the time initial? 1 second. So 9 minus into minus plus 9 plus 1 10 divided by 2. 2 ones are 2 5s are. So 5 meter per second square. So this is what average acceleration, and 4 meter per second square is what instantaneous acceleration. Likewise, you have to find the values. Are you getting any doubts? Shall we do one more problem? Okay. So the example number 2 is displacement is equals to 2t cube minus 60 plus 1. Find out velocity, find velocity and acceleration at t is equals to 2 seconds. T is equals to 2 seconds. Also find acceleration when the velocity is 0. When the velocity is 0. So this is a given question. So pause the video and try the solution. Pause the video and try the solution. 3, 2, 1, go. I am going to solve the solution. Have a look. I hope that you have tried the solution. Are you tried? Not? Okay, have a look. So given equation is what? S is equals to 2t cube minus 60 plus 1, right? So what they are asking? Find velocity and acceleration at t is equals to 2 seconds. Velocity and acceleration at a given instant of time is called what? Instantaneous velocity or instantaneous acceleration. So displacement given. So we can find the velocity from this displacement equation. So what is that? Velocity is equals to ds by dt. The rate of change of displacement is called what? Velocity, which is equals to 2 into differentiation of t cube. Differentiation of t cube. How much? 3t square minus differentiation of 60. 6 into differentiation of t is how much? 1. So because dt by dt get cancelled out. So what he asking? Find the velocity at a t is equals to 2 seconds. Okay. So v instantaneous is equals to 2 into 2 3s are 6 into t square minus 6. So v instantaneous we have to find out, just write like this. So this is v is equals to how much? 60 square minus 6. Now v instantaneous at t is equals to 2 seconds we have to find. So v instantaneous is equals to 6 into what is t? 2 square minus 6. 6 into 2 square 4. 6 4s are 24 minus 6. So v instantaneous we got how much? 24 minus 6. 18 meter per second. Next what we have to find? We have to find acceleration. So what is acceleration? The rate of change of velocity dv by dt. So what is the velocity equation we got? So this is the equation of velocity whatever we got. So d by dt of what is v? 60 square minus 6. Are you getting? Then acceleration is equals to d by dt of 60 square. 6 is constant. Differentiation of t square 2t minus differentiation of constant 0. So a is equals to we got 6 to the 12 into t. So we have to find instantaneous acceleration at a time t is equals to 2 seconds. So just substitute t is equals to 2 seconds to get instantaneous acceleration. Are you getting? Easy questions now? Right. So 12 into what is t? 2. 12 to the 24 meter per second square. Are you getting? So this is what instantaneous velocity. This is what instantaneous acceleration. So one more part is there. What is the one more part? What they are asking? Also find the acceleration when the velocity is 0. So when the velocity is 0, we have to find what? We have to find acceleration. So just to take the velocity equation. What is the velocity we got? V is equals to 60 square minus 6. What we have to find? Acceleration. When we have to find this acceleration, velocity is equals to 0. Are you getting? Right. So 0 is equals to, we got a 60 square minus 6. And just substitute v is equals to 0 at the place of this. Okay. So 60 square minus 6. We can take off. Also we can write like this. 60 square minus 6 is equals to 0 for simplicity. And just taking 6 common, t square minus 1 is equals to 0. If 6 comes to this side, it becomes 0. Then t square minus 1 is equals to 0. T square is equals to how much? 1. Then t is equals to, it becomes plus or minus 1. Are you getting? Why we got a plus or minus 1? Square went to that side. It becomes root over 1. Root 1 value is how much? Plus or minus 1. So at t is equals to plus 1 or t is equals to minus 1, we get a acceleration is equals to 0. If you want to check, just substitute this plus 1 minus 1 at the place of t square. Minus 1 whole square. Have a look. V is equals to 6 into 1 square minus 6. 6 into 1, 6. 6 minus 6, 0. If you substitute minus 1 whole square is nothing but 1. So 1 into 6. 6 minus 6, 0. So at these two conditions we got velocity is equals to 0. Now we have to find the acceleration. So what is the equation of acceleration we got? Acceleration is equals to 12t. Acceleration is equals to how much? 12t. Are you getting? Are you getting any doubts? Just taken a acceleration equation. Okay. So acceleration is equals to 12 into, if you substitute plus 1, you will get 12 meter per second square. So this is the first acceleration. So one more acceleration we will get 12 into minus 1, that is equals to minus 12 meter per second square. So what are these? These are the values of two accelerations when the velocity becomes 0. Are you getting? Any doubts? You are a good student now. You don't have any doubt. Concept is clear. So they are given displacement. We are find a velocity. In this velocity we are substituted t is equals to 2 for instantaneous velocity. So this is the velocity equation. So from this velocity equation I find just acceleration. Acceleration is equals to dv by dt. Then I got acceleration. How much a is equals to 12t. I want to find instantaneous. So what is instantaneous? Just substitute t is equals to 2 because t is only given now. So 12 to the 24. Next condition we given. Also find the acceleration. We have to find this acceleration when the velocity becomes 0. Just I took a velocity equation. In this velocity equation, what is velocity? 0. And just substituted 0. Then I take the common 6. T square minus 1 is equals to 0. If 6 went to that side, it becomes 0. T square minus 1 is equals to 0. T square is equals to 1. T is equals to plus or minus 1. And just substituted T is equals to plus or minus 1 in acceleration equation. Then we got two accelerations, 12 meter per second square minus 12 meter per second square. Any doubts? Are you getting? Right. Pause the video and write the notes. 3, 2, 1, go. The next example. So example number 3. At this time, I am taking a displacement as a vector. So displacement is equals to 2t cube I cap minus t square j cap, let us say plus j cap. Find the velocity, comma, speed and the acceleration at a t is equals to 1 second. At t is equals to 1 second. What he asking? He given one displacement equation. At this time the displacement equation is in the form of vector. So now what he is asking? He is asking to find the velocity, speed and acceleration at a time t is equals to 1 second. So at a time t is equals to 1 second, particular interval of time. That means what? It's a instantaneous velocity, instantaneous acceleration. But the condition is here displacement is in the form of vector. Displacement in the form of vector expression. So how to solve? Have a look. Solution. I'm just taking the given equation. S bar is equals to 2t cube I cap plus t square j cap. Okay. So I'm just taking the vector form of a displacement vector sx I cap plus sy j cap. Sx I cap, sy j cap. So at the place of sx we have 2t cube. At the place of sy we have t square. I'm just comparing these two equations. Are you getting? Right. Very good. So sx is equals to, we got 2t cube and sy is equals to, we got t square. Sx is equals to 2t cube, sy is equals to t square. Now what we have to find? We have to find velocity. So velocity x along x direction, velocity is equals to dsx by dt, dsx by dt. Now just to differentiate this equation, you will get 2 into 2 is constant, t cube, differentiation of t cube, 3 into t square. So 2 3s are 6t square. So this is what Vx. This is what Vx. Next comes to here. So next what we have to find? Vy. What is Vy? dsy by dt. Just to differentiate this equation. Just to differentiate. So differentiation of t square, you will get what? 2t. So Vy is equals to how much? We got 2t. Now what we have to do? Again we have to write off this velocity component or this velocity quantity in terms of vector. So V bar is equals to Vx I cap plus Vy j cap. Vx I cap plus Vy j cap. So this is equals to, what is Vx? 6t square I cap plus what is Vy? 2t j cap. Now what we have to find? We have to find instantaneous velocity. Instantaneous velocity. Instantaneous velocity at what time? T is equals to 1. Are you getting? Okay. I'm just substituting the value of t at a velocity equation. So 2 into 1 into j cap. So 6 into 1 square, 6 I cap plus 2 into 1, 2. 2 into j cap, 2 j cap. So what is this? This is an instantaneous velocity at a t is equals to 1 second. What he asking? He asking speed. So how to find the speed? So speed is nothing but just magnitude of velocity. Magnitude of velocity gives what? Speed. So what is the magnitude of velocity? So this is the velocity equation we got, 6 I cap plus 2 j cap. I'm already told you that how to write the value of magnitude in this type of cases in our previous classes. So 6 square plus 2 square under root 6 square plus 2 square. So 6 square 36, 2 square 4, 36 plus 4 40. What is 40? Meter per second. So this is what? Speed. 40 meter per second is what? Right. So next what we have to find? We have to find acceleration at t is equals to 1 second. To find the acceleration, we want one velocity equation. So here the velocity equation is there. Are you getting? So v is equals to 60 square plus I cap plus 2t j cap. So v is equals to, we got 6t square I cap, 6t square I cap plus 2t j cap. So what is acceleration? The rate of change of velocity. Just to differentiate this equation, 6 into the differentiation of t square 2t I cap plus differentiation of 2t, 2 is 2, differentiation of t is how much? 1 into j cap. So acceleration we got 6 to the 12t I cap plus 2 j cap. So we have to find instantaneous acceleration. Instantaneous acceleration at a time t is equals to 1 second. So instantaneous acceleration is equals to 12 into 1 I cap plus 2 into j cap. So 12 into 1, 12 I cap plus 2 j cap. So what is this? Instantaneous acceleration. Are you getting ma? Any doubts? So likewise, whenever the vector formation of questions are given, you have to solve like this. Are you getting? Any doubts? Then pause the video and write the notes. Right. 3, 2, 1, go. Right. So let us see one concept. So what is the concept? Concept is concept. Alright. First one. If displacement is equals to t square, displacement is equals to t square, find out velocity. Find velocity. Yeah, sir. What the concept it is? It is a easy concept you are taking. So, sir, velocity is nothing but ds by dt, sir. ds by dt, sir. So, ds given, sir. d by dt of s is nothing but what? T square, sir. So, d by dt of t square. So, v is equals to 2 into t. So, this is a velocity, sir. v is equals to 2t. Right, very good. Now, if velocity is equals to 2t, find out s is equals to how much. Now, how can you find the displacement? This is the question. Think, think. Can I say? Can I say this? 3, 2, 1, go. Right. So I'm just taking the velocity equation. What is velocity? ds by dt. ds by dt. So from this equation, I'm just writing ds is equals to vdt. ds is equals to vdt. So I'm just integrating on either side. Integrate on either side. So if you made integrate on either side, then you will get, so integration of ds is equals to integration of vdt. Are you getting? So differentiation, integration cancel out. Then we get a displacement is equals to integration of what is v? qt into dt. So which is equals to 2 into integration of t dt. Integration of t dt. So what is integration of t? Already I told you in a integration concept. Integration of x dx, integration of x to the power of n into dx. So if you are not watched that video, just watch. So integration by Rakesh sir, you will get all the integration formulas. Integration of x dx, x to the power of 1 plus 1 by 1 plus 1, x square by 2. Then here we get t square by 2 plus c, where c is constant. 2 get cancelled out, and we got our displacement is equals to how much? T square plus c. Have a look. What we have taken, s is equals to t square. What we got, s is equals to t square plus c. But c is depends upon given conditions. Okay. So we got t is equals to s is equals to how much? T square. So what is the formula? S is equals to integration of v dt. S is equals to integration of v dt. Okay. This is the formula. Right. So next, if velocity is equals to t cube, find out acceleration. Find acceleration. Right. Are you able to see the board? Oh, solution. Easy solutions are, we know how to find the acceleration when they are given the velocity. So acceleration is equals to the rate of change of velocity dv by dt. So acceleration is equals to d by dt of v given t cube. So differentiation of t cube, we know now sir, 3t square. So this is what acceleration. Now if acceleration is equals to t cube, find the velocity. Acceleration is equals to t cube, then find the velocity is equals to how much. Then how can we find? Same equation. Acceleration is equals to what? dv by dt. We have to find velocity. Then dv is equals to a into dt. So just integrate on either side. So if we integrate, so integration differentiation get cancelled out, which is equals to integration of a is how much? T cube dt. Integration of t cube, we get a t power 4 divided by 4 plus c. So what is this? This is the condition for velocity. So this is the value of velocity. So they are given. So initially the object is at rest when t is equals to 0. If object at rest at t is equals to 0, just substitute this condition. They are given like this. Okay, now they are given conditions like this. Just we have to substitute. Object is rest means velocity is equals to 0. Time t is equals to 0 given. So 0 plus c. Then overall c is equals to how much? 0. Just substitute t is equals to 0. C is equals to 0 here. Then you will get v is equals to t power 4 by 4. This is your answer. Okay. So likewise, we have to find. So acceleration given. How we can find the time? So by using the integration of this one. Okay. By using the integration of this formula. Note. Important formula. Okay. So acceleration is equals to, we can write dv by dt. Acceleration is equals to, we can write dv by dt. So I'm just writing this equation as dv by dt into ds by ds. I'm just multiplying and dividing this equation with ds. Okay, I'm just multiplying and dividing with ds. So I'm just rewriting this equation as dv by ds into ds by dt, and just interchange the positions of dt and denominator ds. So this ds I'm just placed at the place of dt. At the place of ds I'm just placed the dt. Okay. So dv by ds into ds by dt. What is ds by dt? ds by dt is nothing but what? Velocity. Velocity. So acceleration is equals to, we can write, so velocity into dv by ds. Velocity into dv by ds. So this is also an important formula. Are you getting? So how many formulas we got? So this is a first formula. So second formula is what? Whenever displacement given, integration of ds is equals to integration of v dt. So third formula. So whenever acceleration given, so dv is equals to integration of a dt. So just write these formulas in a, okay, just write these formulas. Okay, by using the integration, we can find the displacement when velocity given. We can find velocity when acceleration given. So like this. Are you getting? Right. Pause the video and write the notes. Right. So this is the end of the today's session. I hope that you understood how to find the acceleration whenever velocity given. So velocity is given, then where acceleration is equals to dv by dt, instantaneous acceleration. So whenever displacement given, so first we have to find the velocity. Velocity is equals to ds by dt. Then we will get what? Velocity equation. After that we have to find acceleration. What is acceleration? A is equals to what? dv by dt. So if they are given like a vector form, in a previous question we solved. So if a velocity given and the displacement we have to find, so we have to do like this. So by using these formulas. Okay. So this is one extra important formula, you have to remember it. Okay. So I hope that you understood this class and you enjoyed this class, right? So we will meet on next lecture, motion in a straight line 05. So this is Rakesh signing off. Jai Hind.